All right, so in this video, we're just going to look at some simple radicals or square roots and cube roots and how to simplify those. So, the way that I do this is I'm going to build a factor tree for 244. So that would be, 2 divides into it, which would leave 122. And then 122 divides by 2, and that would leave us 61. Now 61 is a prime number, so I know I can stop there. Now if we look at our leaves here, the 2 2's, and since we're dealing with a square root, we're looking for pairs of numbers that we can pull out of this. So those 2's will come out of the square root as a 2, and then whatever is remaining here will go under our radical again. All right, you may have learned it by trying to find the largest perfect square factor of 244, and the largest perfect square that will go into 244 is just 4. So 244 could be rewritten as 4 times 61, and since this is the biggest perfect square that'll go into it, we know that that'll be what we want to split it up as and pull that square root of 4 out, leaving us with a 2 for that part, and then the 61 left over. This one is going to be a cube root. So instead of looking for pairs like we did here, we're actually looking for groups of 3. All right. So I know I can go ahead and pull the 4x out here. That can go ahead and go out front. 24, that's 8 times 3. And then 8 is a 2 times 4. And then 4 is a 2 times 2. All right. So I've got 3 2's here. Those 3 will come out of the radical as 1, 2. All right. That 3 is going to be staying on the inside. I'm dealing with a cubed root here. All right. Now if we look at our x's, we've got 8 x's. So 1, 2, 3, 4, 5, 6, 7, 8. And we're looking for groups of 3. So that would be one group, and that would be the other group. So those will get to come outside of the radical. So we'll have an x to the second power, and then these 2 would stay on the inside. So an x to the second power. Right. And then you would just simplify this as best you can. So that would be 8 and then x to the third, and then times the cube root of 3x squared. All right. Now the ones that we're going to be dealing with for now mostly are going to be division with radicals. All right, now this one is kind of a special case because you're able to simplify this without having to learn the trick that'll be in the next video. So what you want to do is simplify on the outside of the radical. So 6 and 4, those can both be divided by 2. So that'll become a 3, and this will become a 2. And then the x and the x to the third, well, this will cancel with one of those, leaving us 2 up here. All right. And then you can also simplify within this radical. All right. 2 of these is going to cancel with 2 of those. So that'll make that a 3. And I know we're getting a little messy, so let's go ahead and rewrite it over here. So we've got 3x to the second on top, and then a 2 on the bottom. Now, this 12 and this 15, we can go ahead and simplify those. Both can be divided by 3. So that's going to leave us on the inside of the radical. If we divide that by 3, that'll become a 5, x to the third. And divide that by 3, that'll become a 4. All right. And then the square root of 4 right here, because this is nice and everything else canceled, we can just simplify this. Square root of 4 is 2. 2 times 2 will give us a 4 in the denominator. 5 won't simplify, but x to the third will. We're looking for pairs. All right, since we're looking for pairs and they have x to the third, one group of 2 will get to come out, and it will add to that x to the second. So we'll have 3x to the third because we already had 2 and we pulled one group of 2 out. and then we'll have a 5x left over. All right. Now the goal here is always to make sure that this radical is completely simplified. Nothing will simplify within the the common parts, and you also never want to leave a radical, any type of radical, in the denominator. All right. We'll look at a rule next time that will help us to never do that. All right. It'll be cases like, let's say we had to simplify 8 over the square root of 6. There's no simplifying here, top to bottom, like we could do here, 15 and 12 simplified by 3. So I'll show you next time how to take care of stuff like that.